Bart. I'm reporting live for Premier from the ISC conference in Frankfurt. And we're here with Keith Morris, who is product manager for the Tesla in NVIDIA. So welcome. Can you tell a little bit about what you do?
So my team is responsible for the product management of all of the GPUs that go into the data center from NVIDIA.
What are the new developments during the past year of the Tesla?
So, the big news of the show is that we're now powering the number 1 and number 3 supercomputers in the US with our V100 Tensor Core GPU. Not only that, our GPUs are now the most powerful, or powering the most powerful supercomputers in the US, Europe, and Japan.
It's all done with the Teslas.
Yeah. Yes.
Yeah.
Yes.
Do you know the biggest machines in Europe that you have with Tesla?
Yes. So it's CSCS PIS-8 in Europe, and then it's the ABCI system in Japan.
Okay, so basically you have the biggest machines in the US, the biggest machine in Europe. So yeah.
Yeah.
Okay, great. Can you tell a little bit about the technology?
Yeah, so our Tensor Core GPUs support multiple precision. So this means that they're great for HPC, so we can do double precision, single precision, and now also with Tensor Cores, we can do mixed precision, which is great for AI. And this is really important as we see HPC and AI come together. So on the AI front, they're borrowing techniques from the high-performance computing world. And in high-performance computing, people are finding ways to use AI to solve problems in different ways.
I saw somewhere also machines that were said to be the biggest GPU with having 1 petaflop. Were they also built from Teslas or not?
Just an example, this DGX2 machine is actually 2 petaflops of AI performance, so 2 petaflops of mixed precision. And it has 16 Tensor Core GPUs interconnected by some new technology which is called NVSwitch. So this allows any 2 GPUs to talk to each other at full bandwidth, which allows you to treat this as like one massive GPU. We like to call it the world's biggest GPU.
Yeah, there are of course different modules, but anyway, yeah.
Yeah, well they all work together as one, and you can all work together on one problem.
And as I said, am I correct that it's more than 1 petaflops?
This is 2 petaflops.
2 petaflops. What precision?
So this is 2 petaflops of FP16.
FP16.
So FP16 input, FP32 output.
And if I would do it 64 bits? What?
Oh, 125 flops of double precision.
Yeah. Well, it's still very impressive.
It's still very fast.
It's still very impressive. Yeah. Okay. So what are the next developments of the technology?
So Volta GPUs are everywhere, and really the next development is enabling people with the software. So one of the other announcements of the show this week was we've introduced another 9 containers for high-performance computing applications on our NGC service. So this is a way people can get the software and run on our GPUs very easily, even if they're not experts in packaging software. If they're domain experts in a certain area, they can get straight on and do the science rather than worrying about how to put all the software together to do that.
Mm-hmm. Do you have set up special collaborations to get that kind of applications running?
Yeah, so we have a really strong program in terms of working with developers, and we have over 550 applications accelerated for GPUs. So we do have a very strong program in terms of working with developers, working with independent software vendors to get their software to take advantage of GPUs, such that our customers see tremendous value when they run their applications on a GPU basis.
You work together with universities about that too, or how do you?
Yeah. We have a program called NVAIL, which is the NVIDIA AI Labs.
Yeah.
So we sponsor universities around the world for doing research in AI, and then we also have other ambassadors around the world who work on accelerating their codes in universities.
If you have a lot of GPUs that you need in your application, how do you program that? How can you do that easily?
Right, so there's different levels of getting access to the power of a GPU. So one thing is you can actually just use our libraries. So we develop libraries like cuGlass, cuDNN, libraries that are supported by popular applications and frameworks. So that's one level of leveraging the GPU. The next thing is you could actually use something called OpenACC, which is a performance portable programming language that allows easy access to porting your code for acceleration. This means that with that type of technology, you can very quickly, perhaps within a week or 2 weeks, get a large performance boost on your application on GPUs. And then if you want to go further with the application in terms of tuning it, fine-tuning it, then you can use our CUDA programming language to further optimize the code for your application. And some of the things that we do is we make it easy for people to use multiple GPUs together. We have a library called Nickel. So if you have a machine like this that has 16 GPUs inside, we handle all of the communication between the GPUs and make it look like one large GPU to the programmer. And so a programmer with this machine, they have 512 gigabytes of memory in one GPU effectively. So all of those GPUs are tightly coupled together with the technology NVSwitch. So it looks like one giant GPU.
Okay.
Now, the next thing is, once we've accelerated the applications, how do you get those out to the users and make them easy to install on accelerated machines? And for that, we have a service called NVIDIA GPU Cloud. So somebody who wants to get one of these accelerated applications can sign up for NVIDIA GPU Cloud. It's free. And then we provide ready packaged HPC and deep learning applications for people that are ready to use. So we've gone through the trouble of putting all of the right software together, all of the correct versions of the libraries and the applications together into a container. And so somebody can download that and get going with their application straight away without having to worry about building that from scratch, which could save them days or weeks of effort.
You mentioned that the big machine, the Summit, will be used for HPC, but also for AI. Is that a typical usage, or is still most of the Teslas and NVIDIA used in AI?
So we've been doing HPC for over 10 years. Yep. So we have a large install base of HPC users. But what we're seeing with Summit as an example, this is the new way people are going to build supercomputers. Mixed precision is going to open up lots of opportunities for people to solve problems in different ways. So we think it's very important to have double precision for model simulation and single precision for model simulation. But AI is going to be an important new tool to accelerate applications. And where researchers can take advantage of AI, they can see speed-ups versus regular model simulation of thousands, if not hundreds of thousands of times. And that makes problems that were once intractable now possible. So we think that's really exciting.
Thank you very much for this interview.
Okay, thank you.
For Premier Magazine, this was Adam reporting.